This is Ms. Black with Open Campus, and believe it or not, we are down to the last module for college, Algebra Math 102. We have made it now to Module 18. And in this module, we are going to sum up what we learned to graph in all the previous modules. And we're going to add a little bit more. So if you look at the title of this module, it's called Graphing Inequalities. And we're going to have to go back to way back when, to the beginning modules, and discuss what the difference is between an equation versus an inequality before we can even graph them. So if you take a walk with me to the whiteboard, let's look at that first. Okay, so let's go back to the beginning. Back in the beginning, the first part of this course is all about solving, getting a value for x. And if you look, if I write x plus 3 equals 5, we know that's an equation because it has an equal sign. If I write x plus 3 is greater than 5, we can solve that, but that's now called an inequality because it does not have an equal sign. It has a greater than or less than. So before we can actually graph inequalities today, we have to make sure we understand the difference between an equation versus an inequality. And it goes back to the solving part. So let's just review. If I asked you to solve this equation, that means to isolate the variable. So to get x by itself, you all would subtract 3. And your solution set would be x is equal to. So what does that mean when x equals 2? Well, we all know that means that's the only answer. The only answer that will make this equation balance is the number 2. Do we have to draw a number line for that? No, we could if we wanted to, but why waste time drawing a number line by putting a point at 2 and saying that's the only answer? So we know when we solve equations, we get specific number solutions. We've already discussed this. Module 1, solving a linear equation, 1 solution. Module 4, solving a quadratic equation, 2 solutions. Now we're going to go back and solve an inequality. Well, you do the same method. The method to solve an inequality is just like solving an equation. You isolate the variable. So we're still going to move to 3 by subtracting. We're going to get x is greater than 2. Does x is greater than 2 mean the same thing as x is equal to 2? Absolutely not. Greater than 2 means there's many solutions. There's that Buzz Lightyear world, infinite. There's an infinite amount of solutions. Because you can't list every number bigger than 2 on your paper, do you remember we drew a number line? So if you recall, when we were doing inequalities, we had no choice. We had to draw number lines. And to show that your numbers are greater than 2, we did some shading. So here's 2, greater than 2, shaded to the right. And to show the numbers that were greater than 2 meant we couldn't include the number 2 when we put that parenthesis. So what I want you to notice is this. Solving an equation, solving an inequality follows the same procedure. What was different was at the end. When you stated the solution, the answer, with an inequality, you had 2 decisions to make. You had to decide which way to shade, and you had to decide on a symbol, which with the number line was either do you use parentheses or brackets. Well, people, today, to finish up this whole course, we've been graphing equations. We have graphed linear equations, horizontal lines, vertical lines, diagonal lines. They are equal signs in them. We have graphed circles. X minus h squared plus y minus k squared equals r squared. We have graphed ellipses, hyperbolas, and parabolas. They all had equals. We just graphed exponential equations, logarithmic equations. They've all had equals. What we're going to do today in this last module is take away the equals and put an inequality symbol, a greater than or a less than. It's not going to change the way you graph. It's going to change what you do once you get the points plotted. Because when you deal with inequalities, the process is the same. It's how you show the solution at the end. And when you show a solution for an inequality, you have to shade. So today, after we plot the points and connect the dots, we're going to have to do some shading. We're also going to have to make a symbol decision. And in graphing inequalities, you don't put parentheses and brackets. I'm going to show you what symbol you decide. So let's go back to the notes and let's see what I have. Okay, so we just said the major difference between equations and inequalities are shading and a simple decision. Okay, makes sense so far? All right, what's going to happen with your inequalities is this. The first decision you're going to make is once you plot the points, you're going to have to make a decision whether to make, when you connect those points, whether to make the line of the curve solid or broken. We've been drawing solid lines. You connect all the points, you draw a line. We've been drawing solid curves. You take the points, you connect them, you make the full curve. You know to make something solid when there's an equals, because we've been drawing everything solid and we've been dealing with equations, and equations have equals. So if your symbol is greater than or equals or less than or equals, you're still going to keep the curve of the line solid. What's different is if you don't have an equals. If your inequality has just a greater than or a less than, then you can't make the line of the curve you graphed today solid. You're going to make it broken. Do you remember when we drew the asymptotes in for the hyperbolas, how we said they were invisible, so we made them broken? Or do you remember when we graphed the parabola and we put in the axis of symmetry and it was invisible, so we made it broken? Well, that's what we're going to do today. If you're graphing an inequality and you have less than or greater than, that means those points you plot are not part of the solution. To show they're not part of the solution, we're going to make the line or curve broken. So once you plot the points and you connect the points by either a solid or a broken line or curve, then you're going to have to decide on shading. And depending on what you graph depends on how you shade. So I have here a little chart for you to remember. If it's a vertical line, greater than will shade to the right, less than is going to shade to the left. If it's a horizontal line, greater than shades up, less than shades down, and so on. So we'll go through each of these scenarios in a minute, how you decide which way to shade. So basically today, all we're going to be doing is reviewing your graphs. We're going to review linear graphs and nonlinear graphs. And what you got to ask yourself on all these examples we graphed today is, first of all, you got to ask yourself what you're graphing. You should be able to make yourself a decision what you're graphing. Then you're going to have to make a decision whether you make these graphs solid or broken. And then the third decision is which way to shade. So let's go up to the whiteboard and get started. All right. So pretty much this module is putting everything together you have learned. Love it. We're reviewing. I want you to draw me today a picture of x is less than or equal to 2. So what you have to first decide, guys, is this a line or a curve? Is it linear or not linear? It's x to the first power. It's obviously linear. If it's linear, then which type of line am I asking you to draw? Horizontal, vertical, or diagonal? This is a memorized fact. If it's x equals, it's a vertical line. So now you got to think back to our previous modules. How do you graph a vertical line? You just read the equation. So now we're just going to read the inequality. It says x is less than or equal to 2, which means we're still going to go to the x-axis. We're going to go to 2. Plot a point. To draw a vertical line, you need another point either up or down. It doesn't matter where. Just find me another point that's x value is 2. So the graphing part is the same. We don't do a t-table for a vertical line. We don't put it in slope-intercept form. We just read the equation. Here's the new part. Do you make this line solid or broken? If it has an equals, you keep it solid because you're saying the points you plotted are part of the answer. If it doesn't have an equals, you make the line broken. A broken line means the points are not part of the answer. So if you look, I have an equals, this is solid. Any point whose x value is the number 2 is part of the solution. So there's my solid line. But you're not done. Now you got a shade. I want all the x values that are not also equal to 2. I want all the x values that are less than 2. Pretty much what I'm asking you guys to do is tell me, where is every point located that has an x value less than 2? Well, if you take your pencil and put it on the vertical line, if you go less than 2, you'll be going to the left. Do you agree every point in here has an x value less than 2? Now, do you really think you can write me every single one of those points on a piece of paper? No. So that's why we shade. So you take your highlighter, your crayon, and you color. And that's what I should see. All of this is the solution set. Every point here has an x value less than 2. Every point on the solid line has an x value equal to 2. These are all the answer, the solution to that inequality. That's all there is to it. So far, so good. Let's try another one to review. All right, the second one I want to review is graphing y is greater than -3. So again, first thing you're going to do is ask yourself, is that linear or nonlinear? Well, it's linear. It's y to the first power. Y to the first power must be a line. Now we got to recall facts. When you just have the variable y, horizontal, vertical, diagonal. Very good. That we learned was a horizontal line in Module 13. Do you need to do any work to graph a horizontal line? Do you have to set up a t-table? No. Do you need to put it in slope-intercept form? No. You just read. It says go to the y-axis to the number -3. Now I know it says it doesn't equal it, but that's okay. We'll deal with that in a minute. We're going to the y-axis to -3, which is here. Plot me another point that has a y value of -3. That could be over here to the left. It could be over here to the right. Doesn't matter. That's review. The new part is this. Do I make this line solid or broken? Solid means the points I plotted are part of the solution. Broken means the points I plot are not part of the solution. Well, if you do not have an equals, if it's just less than or greater than, then the points you plotted are not part of the answer. And to show that, we can't put parentheses like we did on our number line. We're going to put a broken line. So if you draw a line broken, you are telling me these 3 points I plotted are not part of the answer. Because these 3 points, y value is -3, and -3 is not greater than -3. Now, we're not done. Not only do you have to decide which to make the line solid or broken, you got to do some shading. So again, take your pencil, put it on a horizontal line. This says greater than. Greater than would be going up. So to shade a horizontal line, your pencil either goes up or down. Greater than is up. I want all the y values that are bigger than -3. So then you would take your highlighter, and I mean you would color all of this in. There is no way on earth you can list me every y value of every point that's greater than -3. So this is a visual picture of where all the points are located that have y values that are bigger than -3. So all we did was review and add a little bit more to it. Are you okay? I hope so. All right, let's look at another one. Give me a minute though. Let me clean off our graph. Our graph is getting kind of messy here. So let's clean it off. And while I'm cleaning it off, look at your next inequality. So I want you to take a minute and look at example 3 and make some decisions. The 3 decisions you want to make by looking at that inequality is, first of all, is it linear or not linear? All right, that's pretty good. All right, so let's look. We have 2x minus y less than or equal to 5. So, sweeties, we're back to basics. You look at that inequality. You decide, is it linear or not linear? That's obviously linear. It's x to the first power. It's y to the first power. Well, if it's linear, a line, which one is it? Horizontal, vertical, diagonal. Good. If it has an x and a y, we know this is going to be a graph of a diagonal line from Module 13. All right, is it ready to graph? Nope. We've already discussed this. There are 3 ways to graph a diagonal line. Setting up a t-table, finding its x and y intercepts, and putting it in slope-intercept form. Out of those 3 methods, which one's the quickest? Very good, slope-intercept form. So I don't have a problem if you do a t-table, you're just doing extra work. I don't have a problem if you find the x and y intercepts. You're doing extra work. The quickest way to graph a diagonal line is putting it in slope-intercept form. What is slope-intercept form? Very good. It's y equals mx plus b. We want to isolate y so we can get the slope and the y-intercept. Well, we know how to do that. How do we get y by itself? We subtract 2x. Watch your signs. You got negative y less than or equal to. Slope-intercept form, we want the x first, and that's a positive 5. Pay attention. That's negative y. Slope-intercept form has to have a positive y. So to get rid of that negative, we divide everybody by negative 1. A negative divided by a negative is a positive. A negative divided by a negative is a positive. A positive divided by a negative is a negative. We have discussed all semester. When you divide by a negative, everybody changes signs. Not only does everybody change signs, but when you divide by a negative number, you also reverse the inequality symbol. Rules from a long time ago. So that is slope-intercept form. Why do we do that? Because now I know the number that's connected by multiplication. I know the number that's behind. The number connected by multiplication is the 2, and its slope, so it's written 2 over 1 as a fraction. The number that's behind is negative 5, and that's our y-intercept. So we all talked about this a long time ago, Module 13. When you get the equation of a diagonal line in slope-intercept form, these are the 2 numbers you need. We talked about this. Begin and move, baby. You begin with the y-intercept. You use m to move. So we're going to go to the y-axis to negative 5. So everybody go to negative 5 on your y-axis. You're going to use our slope 2 over 1 to move. So we're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. That is all review. We haven't done anything new yet. Here comes the new part. Do we make this diagonal line solid or broken? Well, we look at our symbol. Our symbol had an equals in it. Equals means those points you plotted are part of the solution. So anytime you have an equals, you make your line solid. The other decision to make is shading. Anytime you deal with an inequality, as Buzz Lightyear says, you have an infinite amount of solutions. You have many, many answers. To show that, you must shade. Now, here's the problem with a diagonal line. If you put your pencil on it, you got to understand which way your pencil moves. Your pencil either goes up or it goes down. So when we shade a diagonal line, we're not talking left, right. We're only talking up or down. Now we got a problem. The original symbol was less than. Well, less than would mean down. The new symbol in slope-intercept form is greater than. Greater than would mean up. So which one do you use? Do you use the original symbol or do you use the symbol in slope-intercept form? Use your common sense. Did you use the original inequality to graph or did you use the slope-intercept form to graph? You used the slope-intercept form. So because we have to get the equation or an inequality of a diagonal line and slope in a set form, that's the symbol we use. So we're using greater than. Put your pencil on the line. And greater than physically means your hand would move up. So we're shading all of this. So let me get out my marker. I would get a highlighter if I was you guys. Highlighters work wonderful. And you're saying every point here is the solution. Now, do you know how to check if you shaded correctly? Very good. We could just pick a point in the shading and see if it works. If you're saying all these points are the solution, you're saying any of those points, if you substitute them back in the original, would work. Use your common sense. If I let you check to see if you shade it right, which would be the easiest point to check? Very good. 0, 0 is in our solution. It's in our shading. Let's check 0, 0. So we always go back to the original to check, just like we did all semester. 2 times 0 is 0. 0 minus 0 is 0. Is 0 less than or equal to 5? It sure is. If you picked a point and it didn't check, it meant you shaded in the wrong section. Everybody's okay? Good. Let's go to the fourth inequality. All right, let's step it up a notch. So everybody, let's get our fourth inequality. All right, I hope you're having as much fun as I am. I love graphing and reviewing. So that is our fourth inequality. It says x squared plus y squared is less than 9. So let's go through the steps again. First thing for you to decide, is it linear or not linear? All right, think. Linear means the exponents have to be the numbers 1. So what are your exponents? Very good. There's 2's. So this cannot be linear. So that means we're not drawing a line now. Well, oh my. Now we got to think about everything that we learned to graph that's a curve. We learned to graph a circle, ellipse, hyperbola, parabola, exponential, and logarithmic curve. We have learned how to graph 6 curves. It's one of those 6. If you remember your rules, you memorize facts. X squared is a curve. Y squared is a curve. The plus brings them together. Well, that's either a circle or an ellipse. There are no fractions here, which means the denominators are understood to be 1s. And if the denominators are the same, it's a circle. So I expect you to remember from module 14A and B, that's an equation of a circle. Now, to graph a circle, what information do we need? Because remember, we did not do a t-table. We did not do a t-table. It would take too long. What are the key ingredients to graph a circle? Well, if you remember back when, why that's a circle is because it has a point in the middle called the center. And it has a distance you travel called the radius. So if you remember your facts back in module 14A, the equation of a circle is x minus h squared plus y minus k squared equals r squared. We said, obviously the radius is this number if you square root it, because I don't want to know what r squared is, I want to know what r is. The center is h and k, the numbers behind x and y. And remember, we made them the opposite because of the negatives. So everybody look closely. This is my circle. It is in this form. It is x minus what's invisible that you could subtract that doesn't change the letter, 0 squared, plus y minus what's your invisible number you're subtracting that doesn't change the variable, that's 0 squared, equals, what doesn't say equals, it says less than 9. You now have your center, 0, 0. You know your radius. You're going to square root 9, and you're going to get 3. And because radius is a distance, that's why we only use the positive. So this is all review of what you learned. Now, we know which piece of information do we use first in the graph paper. We plot our center, and we move our radius of 3. And to move a radius of 3, it's like a compass. You know north 3, south 3, east, west. All review. Here's the new part. To graph an inequality, you have 2 decisions, solid or broken. Well, I don't see an equals. So that means the points you just plotted are not part of the answer. So to be not part of the answer, you make the circle broken. Doesn't have to be perfect, just don't make sure it's not connected. Now we got a shade. Now, when you shade a circle, your options are either you shade the inside or shade the outside. There is no right or left or up or down. It's either inside or outside. Very simple. Wherever we shade, we should be able to check. So we got a 50-50 guess here. What do you think less than means? I would be like you. I would think less than means maybe the outside. Let's check a point. Let's pick a point on the outside and see if that works. Do you all agree this point's outside the circle? That's at 5, 0. So let's check that. If we put 5 here, what's 5 squared? 25. If we put 0 here, what's 0 squared? 0. 25 plus 0 is 25. Is 25 less than 9? No. So by picking this point, we figured out it doesn't check, which means when you have a less than for a circle, it means the inside. Now I'll prove to you that that is correct. What point is inside the circle? That's the easiest to check. Yeah, again, my origin, 0, 0. What's 0 squared? 0. What's 0 squared? 0. If I add 0 and 0, I get 0. 0 is less than 9. So you need to memorize, if you're graphing a circle, less than is the inside. If this was a greater than, then you would shade all the outside. See how easy this is? We're just reviewing. All right, I believe we have one more example. So let's put up this inequality, and I'm going to let you brainstorm and see if you remember what you're graphing. So our last one, we have y is less than or equal to x squared minus 9. Okay, I'm going to give you a minute to think about that. Your decision is it linear or not linear? That's the first major decision. So look closely. Well, the y is to the first power, but the x is squared. So it can't be a line. It's not linear. So then it's a curve. We graphed 6 curves. Circle, ellipses, hyperbolas, parabolas, exponentials, and logs. Can't be a log. No word log. It can't be an exponential. The x is not in the exponent spot. So then it's one of those conics. Is it a circle, ellipse, hyperbola, parabola? Well, circle and ellipses are x squareds and y squareds with a plus because they come together. That's not squared. In fact, if you remember, when you only have an x squared, that's called a quadratic equation. And quadratic equations are pictures of parabolas. So we know by looking at this equation, because it's quadratic, it's a parabola. Even though it's an inequality, it's still a parabola. Now, to graph a parabola, what were the key ingredients? Good. The most important point on the parabola was your vertex point. Does anybody remember how to get that vertex point? Well, you learned the equation of a parabola has to be written a certain way to get the vertex point. What you've got to have memorized for a parabola is y equals ax minus h squared plus k. That's from module 14. E, F, G. Well, is our inequality set up this way? Sure it is. I got the y, I got the equals. My a is in front, that's 1. I don't have the parentheses. So again, what can you subtract from x that's invisible? It must be 0. So I can rewrite this. X minus 0 squared. There's your k value, minus 9. So we already discussed this. If the equation of the parabola or the inequality of the parabola is in that form, we will see the vertex point. There's my h value, 0. And remember, k stays the same. That plus sign means whatever you see, you keep. So there's your vertex point. Let's plot that. We also learned when you graph a parabola, the number in front, the coefficient in front of x squared, that a value tells you whether it's going to turn up or down. That's a positive 1, which guarantees my parabola, my letter u, is going to turn up. Well, if a parabola turns up, do you all agree it's going to touch the x-axis twice? So now you got to do some work. You got to go find the x-intercepts. Remember, no matter what you're graphing, you cannot look at an equation and know what the x-intercepts are by looking. You have to do some work. To find x-intercepts, you want to know what x is. To know what x is, y must be 0. So remember, to find the x-intercepts, you let y be 0. So you take y is less than or equal to x squared minus 9. You let y be 0. Now here's something you've got to understand. When you say y is 0, that means y is equal to 0. It can't be less than 0. So when you actually find the x-intercepts, even though there's a less than symbol here, ignore it. When you say y is 0, is means equals 0. And now you have to solve that equation. Well, it's got an x squared. It's quadratic. Now we're back to module 4. I know, always going back to stuff you learned. How do you solve a quadratic equation? There's 3 ways to solve this. You can factor it, square root it, use the quadratic formula. Oh, you could also do complete the square. So remember, there's 4 ways to solve a quadratic. The quadratic formula and the complete the square are the longer of the 4. I'm not going to use those. I do not care which method you use. But if I want to do this quick and efficiently, there's 1 or 2 ways. I could factor this using the rule difference of perfect squares, and I would get 2 parentheses, x plus 3, x minus 3. And then when I factor a quadratic, I make 2 linears, and I set them each equal to 0, and I solve. So one solution is x equals negative 3. One solution is x equals positive 3. But wait, I could also take this equation and do the square root method. And if you remember, to do the square root method, you move the constant over. So I get 9 equals x squared. I square root both sides. I know a square and a square root cancel out. That's why I get an x. The square root of 9 has 2 solutions, plus or minus 3. So people, we're on the last set of modules. We can still use information we learned. That's why college algebra is a building block. You take something you've learned and you used it. To graph a parabola, you have to know how to solve a quadratic equation to find the x-intercepts. So one of the x-intercepts here is at positive 3. One of the x-intercepts here is at negative 3. Do you have enough points plotted to graph a parabola? You sure do. Everything we've just done is review a module 14E and F. Now, here's the new part. It had a less than or equal to. Equals means you could keep this a solid U, because these 3 points are part of the solution. Last thing to do is shading. Now we have a decision. Less than either means the inside or the outside. You don't know which one is right yet. You've never done this before. So you have a 50-50 guess. So what do you think less than means for the parabola? Shade the inside or the outside? We'll pick a point and see. Out of all the points to pick, don't you agree 0, 0 is the easiest? So if we take 0, 0, will this make sense? So let me erase all this work. All right, so we want to prove to ourselves which way to shade. We're going to pick the easiest point possible, 0, 0. So that'd be y is 0 and x is 0. Is that a true or false statement? Is 0 less than or equal to, well, 0 squared is 0 and 0 minus 9 is negative 9. Is 0 less than negative 9? Nope. So you are not going to shade where the origin is. So now you have a rule. If a parabola is less than, you shade the outside. And what happens here is you think about it, here's your curve, less than's going down, less than's going down. Now I'm going to prove to you we shaded correctly. Pick any point you want on the outside. So can I pick this point down here? That's 0, negative 10. I'm going to prove to you that's right. So if I pick 0, negative 10, my y value is negative 10, less than equal to, my x value is 0. Negative 10 less than equal to, 0 squared is 0, 0 minus 9 is negative 9. Is negative 10 less than or equal to negative 9? It sure is. So you will always know if you shaded correctly by picking a point in your shaded area and substituting it into the original inequality to see if it works. If it doesn't work, that means you shaded the wrong direction. Now, you're probably thinking, we did a lot in this module. What's left to do? Well, guys and gals, it's kind of boring just graphing one inequality. So when I see you in our last module, we're going to be putting two inequalities together and graphing them. I'll see you then.